Oh yeah, I'll show whatever materials we need, you guys need as well. Alright, we're gonna go over how to make, like just generally how to make schematics. Start by making the project. So, dang. Add a new project, which should be an option. File new, there we go, yeah. Yeah, there we go. File new project. I'm just gonna make this a dummy project. Stop adding the schematic. Then the active BOM. Save all to server so you can back it up on your server. It might look a little different once we get the Somtech server set up. I'm gonna rename this sheet dot. Oop, where did it go? Project should be So when you make the libraries, you're going to add two libraries. One of them is going to be passives. And these are for the passive components like inductors, capacitors, resistors. And you want to add another schematic document or schematic library, which will be renamed actives, which will be like for your FETs or for your IC. Then you will need to create the same thing for your PCB libraries. So you could technically make just one, but we like to keep the organization like this. This is what Aaron told me, so. Yep. Right, and make sure when you generally when you go throughout, just save the thing a lot, because these things update each other. The files update each other as you go, or they should react as you update them. So you need to change them as you go. Now when it decides that it wants to enter the sheet, here. So a good sort of practice to do when you have a sheet to start off with some sort of text string, text frame, or note, or you can use the comments feature. So you can press right, you can comment somewhere on your schematic. We'll start off with just a note, kind of somewhere around. You can title it whatever you want. So for this one, I'm going to be making the 9 volts. I'm not going to go through the whole thing. I'm just going to actually let's do the 15. I'm not going to go through the whole thing. I'm just gonna quickly
around 48 to 15.
So you might want to copy like general information about your design in the notes. I mean, you can title your thing and everything. I'm gonna do that, why not? Text string. This one is 4815. Maybe I should add the volt at the end, why not? Alright, next you should probably change your sheet size to match whatever you're doing. I gotta be real, I don't exactly know how to do this. I kind of forgot. Preference. Let's see. Yeah, preferences. Yeah, just right click on your sheet. Then you have the sheet size and preferences. It can be A, B, C, D. A, B, C, D, E. Normally we're probably gonna be doing B, but for larger ones it's gonna be C or D or whatever. Yeah. Save the server. Right, you have everything in. Now you want to add your very first part. So when you add the first part, it should be the sort of the central chip, the biggest chip with the most pins. That's at the center of your board. And so for this one, it's the LM515 Kurgi, and it's U1. So if we have the tool, this Altium library loader, which you should already have, and you can type this inside, and you're gonna search. And for these kinds of chips, it's gonna be easy because there's only gonna be one kind of design link here. You'll add this to the design. It does a very cool like montage, right? And then here we have this thing in. However, we have a few differences from the schematic that we really want. So the first thing you're gonna, what was this? It's like, man, I should get this. I should get a bunch of stuff cleared out. First of all, the designator isn't right. So you'll notice here it's IC question mark. First of all, it's question mark, and second of all, for IC you want U typically, not like IC. The second thing is that if you go all the way up, you'll see that the pinouts is very different from what's here. It doesn't have this at the top and at the bottom. And so another difference is that if you go into this, you'll see that there are actually no supplier links put in. So if you wanted to make this into the bill of materials, then you wouldn't have any supplier links to put here. So I'm gonna go into the bill of materials and show you how that's gonna start looking like. So make sure it's the right bill of materials, save everything to the server, and then refresh. And then you'll have all the parts listed. And when you don't have like a designator, or you don't have a supplier part number, then it will give you a little error at the top. Alright, so how do we fix all these issues? So the first thing is the supplier link. Do not click here. Okay? That is not where you want to click. Instead, alright, so here's another mistake that I made during this time, which you shouldn't do. So this will lead you into a library, but here you need to change the library to fit the one you want. So we actually want to change it to the library that we are using. Oops. And so what this did is it added the path to my other document, which is let me show you what it is. What went to? This part went right here, which is not right. So I'm gonna delete this real quick, if I can. I love software, guys. It's so interesting. Like you get to troubleshoot. You get to do everything that you want. Make your project super fast and easy. If it's stuck, I'm actually gonna explode right now. My goodness. I don't know. Like you need all the supplier links, all the design rules and everything that you have with Altium. So this is the reason we use it. Alright, so if you recount about a lesson I told you guys earlier, it's about saving your document frequently. So what you're gonna do when this happens, you're gonna go to a task manager. Right, so there we go. That's not something that should happen, but that's the reason we save. And now it's gonna load everything up, even all the stuff that you don't want to load up. There we go. And it's not open. Beefy. Okay. I don't know why it needed to open again, but here we go. Oh, you have to double click to open. Not too fast now. Alright. So we're gonna do this again. I'm not gonna bother with editing it out of the thing. I'm sorry for my wallpaper, guys. Here we go. It's in my folder. Add to design. Jeez, what's its problem? Yep, that's nice. And now we shall observe. Oops, should be inactives. Here we go. We have the component in here, and it has a footprint that goes, if you look at the location, it goes into actives.pcblib, which is what we want. So you have to make sure that the footprint is in, so that when it goes into, when you convert this from the schematic to the PCB, that it actually has the footprint in. So we can go in here and we can observe that the footprint is indeed where we want it to be.
It was placed there automatically because it was put in that setting in library.
Yeah, you have to make sure that it's the correct file in these settings. Which I think is something Aaron missed. Like he didn't check that tab for a while, and he had to manually move everything. Okay. So we go here, and I'm gonna change the designator from IC question mark to U question mark. And we're gonna leave the question mark there because at the end of the schematic you can annotate the schematic automatically, which will give you the right designator based on where the part is. Please. You should be able to edit the supply links. I don't know what's going on, guys. Doesn't work. Okay. Okay, here it works. Huh. Strange indeed. I'll figure that out later. Let's come back to this. You typically just want to delete the part from your schematics, and then, as I said, edit the manufacturer information, and then edit the pinout. So if we look back at our project, we will have these here. So I need not connected to at the bottom. So you can just nice and easy move these around. Not connected 1. Space will flip. Sync out PG good. Sync out. VCC syncing. Make sure the text is oriented so it faces inside, because otherwise it might be flipped. SS DRKey and RT. Ian Uvlo. Yeah. And moving it. Okay. HO at the top. P2. That is the wrong one. And I still cannot edit this apart. You're supposed to be able to. I'm not sure why. Let me show you how it's supposed to look like. You have a schematic library. You have an IC. And you're supposed to be able to see here, be able to change the supplier links. Here we go, yeah. Look at that. Alright, we'll skip this for now. And now we've made all the right changes, we're going to put it back into the schematic document. So it's all saved. Components on the right, where you might need to click panels. From your actives into here. And now it looks all nice like what we need. Okay. Sometimes it has those not connected that are here. Now NC means not connected, but you can clearly tell that they are connected. So we're going to look at the datasheet and make sure this is right. So I can go down here. I'm going to the pinouts, which is typically like in the sixth one. So not connected. No electrical connection. When it says connect EP, which is the exposed pad to ground, which is good. So typically, you might connect the non-connected to the ground so that you get better heat dissipation throughout your chip, especially if it takes a lot of heat. So we're just going to leave this be as the schematic. Right, I'm going to put in one more part for now. And hopefully this one will work a little better. And it's taking the first one here, CBST. This one. Okay. Once again, we have this here. Now, typically what I like to do is just stack these up as I go and then delete them later. But I'm going to delete them now. I have the capacitor here. Here we go. Now I can edit the supplier link. This is what should have happened before. You enter in the same part and observe that you don't have a supplier link. That's fucking perfect. Exactly what I needed to demonstrate. So now that you don't have a supplier link, you need to find a replacement part. And so it can happen sometimes that the part you wanted is not available, or just doesn't have a quick and easy supplier link, so we're gonna need to put it in a different pot. Reject all the cookies. This pot is no longer manufactured, obsolete. Use substitutes. And make sure we have the same sort of statistics as the other one does. So this one 0.1 plus or minus 10 with 25 volts. This one 0.5, 0.1, 25 volts plus or minus 10. Same operating temperature, so we're good. We're gonna take this spot. And paste. Okay, we have two options. We should pick the one that has the symbols already in. So none of this, and make sure it's the same part, which it looks like it is. It's 0603. That's the size. Yep. So I'm gonna add this design. It only has the same footprint, which means it has the same. That's a good thing. If it has the same footprint, it means it's basically the same part. Okay. So this time we should be able to get a correct link on the capacitor. Here we go. Very good. Alright. Now, pop quiz. Which one of these should we pick? Does anybody have an idea? Alright. Good idea. Good idea. Take the cheapest one. But, if you look really closely here at Avnet, you can see that down here, the unit price is 0.01833, but for 4,000, exactly. So that's not the one that we should actually pick. So if you see something like this, just make sure you pick one that with a normal size, which is typically just 1 unit. So you can see 1 unit is going to be a lot more expensive, but we don't use 4,000 units at once. So you're just free to take it. So typically we're just going to use Mauser, digikey, or something else. So Mauser or digikey are your best bets. And you can actually add multiple supplier links, but typically you won't have to unless you have an error, so I'm not going to do it. You can add like the same, a different SPN. So like I want maybe, none of them are 1 unit, so I'm not going to. Right, all good. So now you see that when you import the part, after you save everything to server, then it will have the supplier link. So a little bit of a hazard. If you put the supplier link from the schematic, then not every part that you create from the schematic document will have the same supplier link. So it might not have a supplier link. So you want to put it in the library first. Alright, well I'm just gonna... So this is basically like the how to use the software. It's like a quick sort of tutorial on how to edit the supply links and do such. Let's see, maybe I can get the supply link for this one, as I should be able to. Oh yeah, make sure it has the right number of pins. It has 21, which is good. All the right pins we need. Right, I still can't edit the supply link. I'm not sure why that is. Just how it is, I guess. And at the end you can refresh your schematic document. And so you'll see kind of the part number, the production. So it's typically going to be volume production, obsolete, or let me give you a better one, kind of that shows how it might look like. So you might have unknown, but these are typical. You see here on unknown, we definitely know that they exist because they're the TI chips that we have here. And these ones were on volume production, which basically means they're still being produced. Even is not recommended for new design, which is, you know, production slowing down and there are better parts for this. But typically not recommended for new design is okay for us because we're not too worried about this. And then there's the lower ones, which is like red. It's gonna be obsolete, and you don't want to take that obviously because you're not gonna be able to find that part. And you can look at the unit price or the subtotal here. So if you filter by this, you can check that you don't accidentally have too low of a value, so you're not ordering 4,000 of them, right? Or if you have too high of a value here and you see, oh, I'm accidentally ordering 4,000 of these. That's not good. So the BOM cost might be a little higher than maybe what you planned for, but it's really the PCB and the manufacturing that takes most of this. Let's see. Okay. So now I'm gonna go over a little bit over how you should go about making the right looking schematic, basically. So most schematics are laid out like voltage or inputs on the left and then outputs on the right. So it might be different in Japan or Israel or something like that because they read from right to left, but in the United States of America we read from left to right. So the inputs are going to be on the left, the outputs are going to be on the right. And then you have a ground which should always be facing down like this. To import a ground you just place this kind of object, and then you can place the power port like VCC, and this should always be facing upwards. Okay? And then I'll show you sort of how, let's say, the 3.3 looks like, which I made a little earlier. So if you look here, there are some differences from how this looks and how the other looks. So can you just maybe like name any of the differences you see?
Two capacitors on the right.
Yeah, that's right. So if you generate a schematic instead of making one of your own, then you can observe the BOM count at the top right, and you should note that the total number of components should be equal to the BOM count. However, when I looked through this, I saw that the BOM count was one more than all the components I had placed, and the culprit was this here. So it says capacitor out, C out, but if you look here very closely, you'll see that it says quantity equals 2, and I read this basically as a place 2 of these in series in here. So that's how it should look like, and that's what I commented here. Is this right, Manas? Honestly, I don't
Isn't that
even
crazy? Why would they do that?
like. Why would they do that? I know, right? And then there was one move I had to do like 5 of them in a row. Look at this, 5 of them in a row, and it only showed up one. Pretty crazy.
Did you verify that that was the correct way to I mean,
I have no other way to. I have no other way to check that. It's just.
It just has to work.
It has to, like, it has to meet the BOM count. There's nothing, there's no other option that I have.
That's good problem solving. Yeah.
Yes, good problem solving. Right. Any other like differences? Let me zoom back out. Any other differences that we have between this schematic and this one?
We have the chip on the top. Go back to the other one.
Mm-hmm.
There's that chip on the top.
Okay, so
Or is that just that blue thing zoomed in?
yeah, so that's right. So this is the blue thing zoomed in is an N-channel MOSFET, and so it kind of depends sort of what symbol you import, or what or if it's an IC, or if it's a chip MOSFET, or if it's just or if it just has the free connections here, the source gate and drain, which I'm not sure which way the source gate goes, but yeah, the source goes at the bottom, I think. So it's gonna show up as a chip because, and let me go to the part number to show you how it looks like. Yeah, that happens sometimes. So I'm gonna click here, and I have the data sheet here. So you can check your data sheet from your schematic if you ever need that. So this is how the chip looks, as 1, 2, 3, 4, 5, 6, 7, 8 sort of connections, and I'm gonna zoom in a little bit more, and you can see how they look like. So this is the N-channel MOSFET symbol, and you can see that it shows up right up here as well, because that's the part. So we have three pins. You have the 1, 2, 3 that are connected to source, and then you have the 5, 6, 7, 8 that are connected to drain, and then there's the 4 which is connected to the gate. So in this instance, because we want like good heat dissipation, we're going to connect every single pin to its corresponding thing. So you're connected to all the source, and connected all the drain and all the gate. So yeah, sometimes the components will look different because they're in chip form. So that's a good thing to point out. Do you notice any other differences between these two? It's like a very glaring, obvious difference. I just try and read it from left to right, and you'll immediately see that something's off.
There's not the wire going all the way down.
Yeah, so well, that's not the one I wanted you to see, but it's also true. So we have instead of the wire going all around, it might sometimes be a little easier to name the net implicitly. So you see how on this, if you click here, well, it should give me the, oh my goodness. Okay, yeah, there we go. Physical name and net name is VN. So this is the input voltage net. So what I've done is I've renamed all the input voltage nets to be VN, and you should make sure that they're actually named correctly. If you want to do that, like if you want to name them, you will go into when I reach what it's supposed to be. There we go. Net label. And so you're gonna have to click this on a net. And you're gonna write here. Or what you can do is you can double click and you can choose from here, which is more reliable, because like what if you accidentally name it with a space or a capital letter in between, and then you have two nets that are supposed to be the same, but now you've created them to be different. So the same thing we have is for the power ground, which is very obviously connected to the ground and connected over here. So you'll see that this is equivalent to how it's connected here. It's connected to the ground and it's connected over here. Alright, two more differences. Oh, well, three. They're commented, so you should be able to see them. On the left, we have a missing input voltage. So this is just a placeholder for now. What I would do is place two vias or two pads, or a sort of connector pad that would go here. So then we could so be one pad to a VN and one pad to a power ground, which would be able to make the connection. And it's the same thing with the output current here. So currently we don't have that set up, but hopefully we should. And then final thing, I just have commented this, but it's a substitute. So this isn't the correct. Well, it's the correct part, but it's not the part that's listed because it was obsolete. So you might wanna comment that for later, like if your design doesn't work and maybe it's related to the capacitance, then you can check that maybe your substitute didn't have the correct values. Okay. Do we have any questions arising from all the information stated today?
I just had a problem pulling up the components on my phone.
Yeah. Click. It's disconnected. Look at that.
To catch the bus.
Oh, it's because my internet's down. Now it should go back up, maybe. Here we go. Very good. So, why is this? Okay. So there should maybe be a components tab on the right. Do you have it?
Yes.
So click the components, and then you see this, right?
Yes.
So click on the top, and you're gonna go down to the library that you want, the schematic library that you want. Let me go back to the original document. So go here, and then you should have a list of libraries from your document. Do you have it? Or do you see it? Did you save it to server? Click the save to server. No, this.
Oh.
Yes. Well, click it on for the project that you're doing.
Yes. Makes sense.
Yes. Here we go. Got it.
Okay. And then it should be in here. So I should just search it up now.
Hmm?
Do I search it up and then show
Oh
up?
no. Click on the thing first, and then yeah.
And then search it up.
Well, you don't have a component though, for whatever reason. You don't have your component. So this is just a blank component.
Okay.
Alright guys, any other questions?
How do you get like the Suntech library?
We don't have it set up yet, so for now, just you don't, like, just for now. I think Rudy or someone else who runs all the server stuff being set up. Probably Chen, because he has that nice Wi-Fi.
Yeah, he's that really nice Wi-Fi.
Mhm.
He's talking about how he's gonna start charging us for API token and requests or whatever he was talking about to use the server. So we're all gonna be
Oh.
very soon. He's gonna be very, very rich.
Oh goodness. Oh goodness me.
This is America.
Every time you press that save the server,
Yeah.
we're gonna get charged like a cent or something.
$7
Yeah,
per request. And
Yep.
if it's a bad request, he charges you more.
exactly. Okay, so get out of here. Alright, maybe I'll show you how to annotate at the end. I actually don't know. You might just have to. Yeah, honestly, I don't know. You'll search it up. Like when you annotate the schematic at the very end, you can search it up. I'm not gonna pretend like I know everything. So that was I'm gonna stop it right here, and then we'll talk about general SomTech stuff